All right, our second example that we're going to be thinking about here is going to be the example of thinking about a damped-driven spring, where our differential equation is given right here by 1/5 x double prime plus 1.2 x prime plus 2x. And for the springs, remember our dependent variable is x and our independent variable is t. And the driving is on the right-hand side of the equation. It's this 5 cosine 4t. So it changes in time. There's this cyclic pushing that we're doing to the spring. And then on the left side are like the physical things of the spring, like its mass and its spring coefficient and the drag it's experiencing. I've also gone ahead and written out the solutions to the homogeneous equations, so when it's equal to 0, because we need that. You would solve it with constant coefficients if it wasn't given to you, but I went ahead and wrote them down right here because we'll need them eventually, and it takes a while to get to that point. But I wanted to make sure that I did not have written out ahead of time an important step in this problem. So if you're still copying down the problem itself, go ahead and hit pause. But I want to note that even though we're given the differential equation in this form, remember that our variation of parameters like derivation, so the formula we use, assumes that there's nothing multiplying our highest derivative. So we actually have to get rid of that 1/5 before we get too far in this problem. So we're going to have x double prime plus 6. I know I did the multiplication on this piece of paper somewhere. Yes, it's 6. 6x prime plus 10x, just multiplying 5 everywhere. And the left side actually isn't going to matter much here, but it's going to change our right side to 25 cosine 4t. So if I had forgotten to get rid of this constant right here, all my answers, because remember we like multiply by f and then integrate, they would be off by a factor of 5. So if you're doing your web work and you get the wrong answer and your neighbor's like, oh, well, I multiplied by 2 and it was right, it's not magic, it's because of this. So just watch out because this is a really easy step to miss. So given that correct formulation of the problem, we're going to go ahead with our whole finding the particular solution process. So let's assume that our x sub p is equal to u1 x1 plus u2 x2. Just everywhere I had y before, I'm writing x because we've used some new variables for this spring problem. So that's u1 times e to minus 3t cosine t, and u2 times e to minus 3t sine t. So then I need to compute the derivatives of x1 and x2 as well for us to calculate that Wronskian for the first time. So we've got x1 prime. We're going to need a product rule because e and cosine are multiplied by each other. So if I take, sorry, e to minus 3t and leave it how it is, I would then get the derivative minus sine t. And then I consider the problem where I leave cosine t the way it is. Oops. But then I multiply by the derivative of e, that would give me a minus 3 right there. Again, please, if you can't flawlessly do that in your head all the time, make sure to write out all the steps. Don't let this one thing go wrong early that messes up everything later. x2 prime, I've got that e to minus 3t. First I think about when I take the derivative of sine, that just becomes cosine t. And then I think about when I take derivative of e, I get a minus 3, and sine stays the same, I've got a sine t. And then I can calculate my Wronskian. So I've got x1, x2 prime minus x1 prime, x2. And it's a lot of terms. To save base, you can go ahead and like factor out your e right away, but I'm going to write everything out and then factor it. So my x1 is e to minus 3t cosine t. My x2 prime is e to minus 3t times cosine t minus 3 sine t. Minus, I don't want to lose that minus sign. My x1 prime, e to minus 3t times minus sine t minus 3 cosine t. Sorry, I'm already thinking about how I need to remember that minus multiplying that minus. And then my x2, which is e to minus 3t sine t. It's a lot, but look how we've got this double of e to minus 3t showing up. So I know that that's going to be an e to minus 6t when I add together those exponents, and it multiplies everything in my entire problem. Then what's left over is cosine times cosine gives me cosine squared t minus 3 cosine t times sine t. I just did this distribution. And then here, I know that this is going to be pluses when I distribute my minus. I'll go ahead and write that. And then I just need to multiply them both by this sign. So I'm going to get plus sine times sine is sine squared t plus 3 times cosine t sine t. So I've got this minus 3 cosine t sine t plus 3 cosine t sine t. Those cancel out, very exciting. And I'm just left with e to minus 6t times cosine squared t plus sine squared t. And if you don't remember, there's a property that tells us that cosine squared plus sine squared is 1. So this is actually just e to minus 6t times 1. So it started out with a lot of terms, but we're actually just left with that e to minus 6t at the end, which is really nice. We're going to have to plug in to get our u1 and u2, and I'm going to move to my next slide to do that. So please pause if you're still working through that simplification. I will drink some coffee to give you time to pause. And now, we've got that u1 prime is supposed to be minus x2 times f divided by x1, x2 prime minus x1 prime, x2. And u2 prime is x1f divided by x1, x2 prime minus x1 prime, x2. So we just have to plug in what our x's and f's are. Let's see, my x2 was the e to minus 3t sine t. And remember, our f has to be this version of it that we multiplied by 5 to isolate x double prime. So it's times 25 cosine 4t. And then all that's divided by that e to minus 6t that we found on the previous slide. And so e to minus 3t divided by e to minus 6t is e to minus 3t times e to 6t. So that's going to become e to 3t. And I'm going to pull my number out front, minus 25, sine t cosine 4t. So if this simplifying the exponents was difficult to you, I find it easier to always get rid of things in the denominator, just swap the sign, and then you do your normal adding or subtracting exponents. And then for u2, my x1 was e to minus 3t cosine t, and our f is the same, 25 cosine 4t, divided by e to minus 6t. So again, that same simplification gives us e to 3t times cosine t times cosine 4t. From here, we would go ahead and integrate, and because we have products of trig functions, we would have to use like special trig substitution to get our integral. Watching me do that is not a good use of your time. I will not give you exam questions where you need to remember tricky trig substitution. So I'm just going to go ahead and tell you that we need to remember that this is u1, u2 prime. I must integrate to get u1, u2. And if I integrated these things, I would get minus 25 over 204 times minus 17 sine 3t plus 9 sine 5t plus 17 cosine 3t minus 15 cosine 5t. Which is a mess and would not be pleasant to integrate. u2 is the integral of u2 prime, which is 25 over 204 e to 3t times 17 sine 3t plus 15 sine 5t plus 17 cosine 3t plus 9 cosine 5t. And I'm missing an e to 3t over there. I'm sorry about that. I'm sure you're very concerned about the accuracy of this integral. You never want to evaluate. But once we have what u1, u2 are, we can solve for the particular solution u1 x1 plus u2 x2. And all these terms have the same like combinations of trig functions, so it actually ends up simplifying a little bit to 25 over 102 cosine 4t plus 50 over 51 sine 4t. Again, this number really shouldn't matter to you. I just want you to remember that these are the steps of the process we follow. And finally, we can write our general solution. X is c1 x1, that e to minus 3t cosine t, plus c2 x2, e to minus 3t sine t, plus our particular solution, minus 25 over 102 cosine 4t, plus 50 over 51 sine 4t. And at this point, you would be done with the problem. I did go quite quickly over these last parts without showing all the steps, because once you've gotten to here, you've kind of set it all up. And this integration can get really long is the only challenge, but as long as you remember to do it and plug everything back in, you'll be okay. So in our last video, we're going to talk about how to handle equations with more than a second derivative.